My name is Vincent de Ville, and I am the chairman of Bureau Goyet. I give also some lecture in the Liège University. Bureau Goyet is a consulting office. We design all type of structure. The last bridge that we have designed is the third Bosphorus bridge, very close to Istanbul. Other iconic structure, of course, is the Milo viaduct that we have designed in the southern of France. Of course, it is an exceptional structure. Why? Because it's an elegant one, and for an engineer to work for this type of structure is very exciting, of course. The founder of our office was René Goyet. For him, the best solution was a simple structure. But to design simple structure is not so simple. Steel construction changed over the last 10 years thanks to the evolution of the quality of the steel. For a bridge, the span lengths can be longer with steel. It's impossible to design this type of span with concrete. Steel materials give us the possibility to have a more slender structure. Of course, one interest of the steel structure is it fully recyclable, and it's interesting of course for us, but also for our children and for the nature. For example, if you look to bowstring bridge that we have designed on the canal between Liège and Antwerp, for these bridges we have made some research to avoid bracing between compression arches. Why? Not only to have a more slender structure, but to obtain a structure easier to build. Here we have the drawing of the steel deck of the Milo viaduct. For the launching method, we pre-assembled the deck on the abutment. After that, we push the deck above the ground. With that solution, 90% of the work is made by workers on the ground, not on the bridge. Of course, it's more safe for them. It's impossible to know everything today, and to have communication relation with professors, with researchers is very important and very interesting for us. For example, for the Milo viaduct, just before the final design of the bridge, it was not possible with our computer program to verify the behavior of the viaduct under the turbulent wind, to take into account the dynamic effects induced by the gust. With the help of university, only 3 months were necessary to develop a new part of our program to take into account this phenomena. And with that, we were completely independent to verify the structure. We have made the full design of this new railway. We have pre-assembled 5 steel arches. And when the arches were assembled by welding, we have pushed it on the distance of 10 meters about. At the end of the operation, we have pushed all the main structure with a total weight of about 4,500 tons, without interruption of train movement. Our job is different each day, because the interest is to optimize the design, to obtain the best solution by using the best tool used by the factories. We have today something to learn, and it's very interesting and enthusiastic for a job.